In this video, I'm going to talk about integration of rational functions. In this video, I will show you different methods to integrate simple rational functions without involving square root or trigonometric functions. Before I start, I'm going to give you a mind map. This mind map will give you a guide about how to choose a suitable method to integrate a simple rational function given. This mind map would help you to organize your information so that it is easier to determine which method is suitable to be used. Now let's look into it. When we are given an integral in rational function, first we must find out whether the rational function is an improper rational function or proper rational function. If it is an improper rational function, then we must change it into proper rational function by using long division method or any other method. Next, if it is a proper rational function, then we must double check whether we are able to change the numerator becomes the derivative of the denominator. If yes, then we are going to use this formula to do the integration. If not, then we go to the third step. That is, if the rational function is in this form, where the numerator is constant and the denominator is quadratic. If it is in this form, then we try to factorize the denominator. Reducible denominator means we are able to factorize the denominator. After factorize, now we use partial fraction to separate it. And after that, followed by using this formula to find the final integration. If we are not able to factorize the denominator, then the rational function will be either in this form or in this form. If the rational function is in this form, then there are two methods can be used. One is by using substitution method, and the other one is by using formula method. If the rational function is in this form, then we are going to do completing the square for the denominator. After completing the square, there are two possible results. If the result here is a minus, then we are able to factorize the denominator and we are going to repeat the same process here. If the result of the completing the square is plus, means we are not able to factorize the denominator and we are going to use this method to find the integration. Next, if the rational function is not in this form, then we should double check whether it is in this form where the numerator is linear and the denominator is quadratic. If it is so, then we must change the numerator into the derivative of the denominator. After this has been done, then we are able to integrate this integral by using this formula. As for this one, we are going to repeat the same step in step number 3. Now we try this question. Since this integration involving a rational function, so first step, I must double check whether the rational function is an improper rational function. If yes, then I need to carry out long division to change it into proper rational function. So from the question, I find that this is an improper rational function. So I'm going to carry out long division. After long division, then I will end up like this. Now I'm going to separate these two terms, becomes two separate integral. As for integration of 2, I can easily get 2x. As for this integral, when we look back the mind map, since the rational function is not improper rational function, then we go to the next step. Now I'm going to find out whether I'm able to change the numerator becomes the derivative of the denominator. When we look at the question, the derivative of 2x plus 5 is 2. So to do that, first I take out the constant 3. Then I simply plug in the derivative of 2x plus 5, that is 2 here. And at the same time, I must divide the same number out here. So up to here, I'm ready to integrate this integral by using the formula here. So after integration, I'll end up with this one, then plus a constant c. C is an arbitrary constant that must be written every time after the integration. Next, let's try this question. Since this rational function is not improper rational function, so we move on step number 2. So for step number 2, we need to double check whether we are able to change the numerator into the derivative of the denominator. So the derivative of the denominator should be 4x minus 3. So we find that we are not able to change the numerator into the derivative of the denominator. So we move on to the step number 3. So step number 3, we find that the rational function is in this form where the numerator is constant and the denominator is the quadratic. So first we are going to see whether we are able to factorize the denominator. If yes, then we will using this step to find the integration. So when we look back, so this is the reducible quadratic where we are able to factorize the denominator. So first I factorize the denominator and I'll get these 2 factors. And if there is any constant here, please take out in order to keep the terms here as simple as possible. This will simplify the working step afterward. So after factorization, now I'm going to do partial fraction. After partial fraction, it will end up with something like this. And before continue, I find that I'm able to factorize 1 over 7 so that we can keep the terms inside here as simple as possible. After this step, I find that I'm ready to do the integration by using this formula, where the derivative of 2x minus 5 is 2 and the derivative of x plus 1 is 1. So after integration, I'll get ln. And according to the law of logarithm, so minus can be changed to divide. And finally, end up with this final answer. Now let's try this question. For this rational function, it is not an improper rational function and we are not able to change the numerator into the derivative of the denominator. And we find that this rational function is in the form where the numerator is a constant and the denominator is a reducible quadratic, where we are able to factorize the denominator. So now I'm going to factorize the denominator by using this formula, where a is equal to square root of 2x and b is equal to square root of 5. Then after factorize, I'll get something like this. And Now I continue doing partial fraction. So when doing partial fraction, first I'm going to choose a suitable value of x such that this factor becomes 0 in order to find the constant b. When this factor is equal to 0, means x is equal to negative square root of 5 over square root of 2. So when I choose x is equal to negative square root of 5 over square root of 2 and substitute into this equation, and I find that the value of b is equal to negative 1 over 2 square root of 5. Then I'm going to choose another value of x such that this factor is equal to 0. When square root of 2x minus square root of 5 equal to 0, then x is equal to positive square root of 5 over square root of 2. So when I substitute this value of x into the equation, then I find that the value of a is 1 over 2 square root of 5. Now, by using partial fraction, now I have separated this rational function into two. Before I continue, I factorize this similar value out so that I can keep the simplest term inside here. Then now I'm going to put in square root of 2 because square root of 2 is the derivative of the denominator. So after this, I find that now I am ready to do the integration of this integral by using this formula. So after integration, I'll get ln. And since according to the law of logarithm, I combine minus under law of logarithm, it becomes divide. So finally, I get the final answer here. Now let's try this question. This rational function is in the form where the numerator is a constant and the denominator is an irreducible quadratic. That is, we are not able to factorize the denominator. When we look back the mind map, if we are not able to factorize the denominator, then it will be either in this form or this form. Now, from the question, we notice that the rational function is in this form. So, there are two methods can be used to find the integration. One is by using substitution and the other one is by using formula. So, first I'm going to show you how to use substitution method to find the integration of this question. So before this, I'm going to rearrange the denominator in this form where square root of 2x is fx and square root of 5 is a. Since we replace fx with a tangent theta, so according to this question, fx is square root of 2x. So means I'm going to replace square root of 2x with square root of 5 tangent theta and dx is equal to this one. Now to do the substitution, first I take out the constant 3 and I replace square root of 2x with square root of 5 tangent theta and dx with this expression. And first, square root of 5 tangent theta power 2 is equal to 5 tangent power 2 theta. And when I factorize the 5 here, I find that this is tangent power 2 theta plus 1. And we know that tangent squared theta plus 1 is equal to 6 squared theta. And next step, I'm going to take out all the constant and 6 squared theta cancelled by 6 squared theta. Now I find that it is very easy to carry out the integration. So after integration, I'll get this. But notice that the question is given in terms of x. So now I'm going to replace data in terms of x. And at the beginning, we know that square root of 2x is equal to square root of 5 tangent theta. That is, theta is equal to inverse tangent of square root of 2 over 5x. Then when I substitute the data in terms of x, now this is the final answer for this question. Now I'm going to show you the second method, that is by using the formula. So first of all, I take up the constant 3 and I rearrange the denominator in this form where square root of 2x is fx and square root of 5 is a. Then, when using this formula, I need the derivative of fx. So, the derivative of fx, that is square root of 2x, is equal to square root of 2. Since square root of 2 is a constant, so I can simply put in the square root of 2, but at the same time, I must divide the same number out here. Now I'm ready to use the formula. But remember students, if you want to use the formula in answering this question, remember you must write this formula clear during the examination to avoid losing mark. So now based on this formula, the integration of this function is equal to 1 over a, where a is square root of 5, multiply with inverse tangent fx over a, where fx is square root of 2x over a and a is square root of 5. And after simplify, now this is the final answer. Now let's proceed to the following question. For this question, the rational function is in the form where the numerator is a constant and the denominator is an irreducible quadratic. That is, we are not able to factorize the quadratic here. If we are not able to factorize the quadratic, and based on the mind map, we need to carry out completing the square for the quadratic. And if the result is a minus here, then we will follow this method. If the result is a plus, then we will follow this method. Now when we look at the question, now I'm going to carry out completing the square. So after completing the square, I find that the result is a minus here. So means we are going to factorize the denominator by using this formula. After I factorize, I get something like this. Then I'm going to do partial fraction to separate the rational function into two. When doing partial fraction, so first I'm going to choose a suitable value of x such that this factor is equal to 0, and then I am able to find the value of b. If we want to change this factor into 0, so means the suitable value of x is equal to 1 plus square root of 6. So when we substitute x with 1 plus square root of 6 into this equation, now when simplify, I find that b is equal to 1 over 2 square root of 6. Now I'm going to choose another value of x such that this factor is equal to 0, and I'm going to find the value of a. Now, in order to change this factor becomes 0, now the suitable value of x is 1 minus square root of 6. Now when I substitute x with 1 minus square root of 6, I find that the value of a is equal to negative 1 over 2 square root of 6. Now, after partial fraction, I have separated the rational function into two. Before I continue, first I'm going to factorize the same value here. Now I realize that actually now I'm ready to do the integration because the derivative of the denominator here is equal to 1 and same the derivative of this denominator is equal to 1. That means we are able to integrate this integral into ln. After that, by using the law of logarithm, so now I change it to divide. Now this is the final answer for this question. Now I'm going to show you next example where the rational function is a constant and the denominator is an irreducible quadratic. So means in this case, we are going to do the completing the square for the denominator. So after completing the square, we find that the result is a plus here. That is, we are not able to factorize the denominator. According to the mind map, there are two methods can be used. One is by using substitution, the other one is by using formula. Now I'm going to use the formula to do the integration. To do this, I rearrange the denominator into this form where fx is equal to square root of 2 times x plus 1 and a is equal to square root of 5. And I need a derivative of fx. So from the question, the derivative of fx is square root of 2. Since square root of 2 is a constant, now I just put in the square root of 2 and at the same time, I divide the same number out here. And remember students, if you want to use this formula method, please write the formula out during the examination. Then by using this formula, I find that the answer is equal to 1 over square root of 5 where square root of 5 is a and multiply with inverse tangent fx over a where fx is equal to square root of 2 times x plus 1 and a is square root of 5. So when I simplify, then that is the final answer. Now let's proceed to the next question. For this question, the rational function is in the form where the numerator is a linear and the denominator is a reducible quadratic. That is, we are able to factorize the denominator. Now for this question, I'm going to show you two methods to find the answer. For the first method, since we are able to factorize the denominator, then I'm going to use this method, that is, first factorize the denominator followed by partial fraction. Then after that, find the integration by using this formula. So now I'm going to factorize the denominator. So after factorize, now I'll get this. And then I'm going to use the partial fraction to separate it into two different integrals. Then because the derivative of the denominator is constant 2, so now I insert the 2 as the derivative of the denominator here, and at the same time I must divide this same number out here. So now I'm going to use this formula to integrate. So after integration, then I'll get this one as the answer. Now for second method, since this rational function is in the form where the numerator is a linear, so when we look at the mind map, so now I'm going to use this method to find the answer. That is, first I try to change the numerator into the derivative of the denominator. So first step, since the denominator is 4x squared minus 9, means the derivative is 8x. So first I separate the rational function here without using the partial fraction. So for this one, since the derivative of the denominator is 8x, so first I take out the 3, then I insert the 8, so that this numerator becomes the derivative of the denominator, and at the same time I must divide 8 here. For this, I can easily integrate becomes ln, and for this one, since the rational function is in the form where the numerator is a constant and the denominator is reducible quadratic, now according to the mind map, now I'm going to use this method to find the integration of this part. So first, I'm going to factorize the denominator, then followed by using partial fraction, I'm going to separate this into two different fractions. Then before I continue, I factorize the common factor here, and I find that I need a 2 on top here because that is the derivative of the denominator here. So now I insert the derivative, that is 2, and at the same time, I must divide the same number out here. So now I'm ready to integrate. So after integrate, I'll get ln. And by using the law of logarithm, now I combine these two ln becomes divide. So now this is the answer of this question by using method number 2. Then some of you may notice that the answer that we get from method number 1 and the answer that we get from the method number 2, they are different. So actually, these two answers is the same. Now let me verify it. Now this is the answer that we got by using method number 1, and this is the answer that we got by using method number 2. To do the comparison, so first I'm going to change the denominator the same. So I change the denominator from 8 to 24, from 12 to 24. So now I start from the answer that we got from method number 1. When we look at the coefficient here, this is 11 over 24, this is 9 over 24. So 11 over 24, I can separate becomes 9 plus 2. And 7, I can change becomes 9 minus 2. Then after that, I separate this fraction becomes 9 over 24 plus 2 over 24 and 9 over 24 minus 2 over 24. Now I take the term with the same coefficient, that is 9 over 24 and 9 over 24. Here, this one 2 over 24 with 2 over 24. When I factorize the coefficient, so I get 9 over 24. So after factorize the coefficient, I can combine the ln by using the law of logarithm where addition becomes multiplication. So when I multiply this one with this one, then I'll get this one. As for this one, similarly, I factorize the coefficient 2 over 24, and by using the law of logarithm, minus becomes divide. So when we compare this answer, so actually the answer is the same as the answer that we got in method 2. Now let's proceed to the next question. For this question, the rational function is in the form where the numerator is a linear and the denominator is a reducible quadratic, where we are able to factorize the denominator. For this question, I'm not going to use the method 1 as I did in question number 7, because even though we are able to factorize the denominator, but the product of the denominator, we notice that these numbers are not in integer. If these numbers are not integer and the numerator is linear, so when we continue to do the partial fraction, then we will find that it is very complicated to find the constant a and b. So now I decided not to use method 1. Now I'm going to use method number 2, same method as question number 7, where I'm going to separate the rational function becomes 2 without using partial fraction. So for this, I try to change the numerator becomes the derivative of the denominator. So for the derivative of the denominator is 4x. So first I take out the 3 and I add in 4 so that this one becomes the derivative of the 2x squared minus 5, and at the same time I divide the 4 out here. Now for this one I can easily integrate, becomes ln. Now for this one, this is the rational function in the form of where the numerator is a constant and the denominator is reducible quadratic, where I'm able to factorize the denominator. So after factorize, I find that I get this one. For this one, I can continue using partial fraction because the numerator is a constant even though these numbers are not in integer. So when I continue by using partial fraction, so I can separate this rational function into 2. So now before I continue, first I take out the common number so that I can keep the simplest form inside here. So for this one, I'm going to put in square root of 2 because square root of 2 is the derivative of the denominator, but at the same time, I must divide the same number outside here. Up to here, now I'm ready to do the integration. So after integration, I'll get ln. And by using the law of logarithm, I change minus becomes division. So now this is the final answer. Now we proceed to the following question. For this question, the rational function is in the form where the numerator is linear and the denominator is irreducible quadratic. When we look back the mind map, if the numerator is linear, now we are going to change the numerator into the derivative of the denominator. So now I'm going to change the numerator into 4x plus 2 because 4x plus 2 is the derivative of the denominator. But notice that the numerator here is 3x minus 2. So first I'm going to take up the constant 3. Before we can take up the 3, we must factorize the 3 for this numerator. So after factorize the 3, we will get x minus 2 over 3. So next, I'm going to multiply the numerator with 4 because the derivative is 4x. So when I multiply the numerator with 4, then at the same time, I must divide the same number out here. And since the derivative is 4x plus 2, then we still short of plus 2. So now I insert plus 2 and at the same time minus 2 back. And I combine negative 2 minus 8 over 3 becomes negative 14 over 3. And now I'm going to separate this rational function into two parts. One is 4x plus 2. One is negative 14 over 3 without using partial fractions. So after separate, I find that I can easily integrate this part into ln. Now as for this one, after simplify, I'll get something like this. when we look at this one, this rational function where the numerator is a constant and the denominator is irreducible quadratic. When we look back the mind map, for constant and irreducible denominator, that is, we are going to carry out completing the square. So after carry out completing the square, I'll get this one. Now I'm going to focus at this part. So when we look at the rational function here, after the completing the square, this is a plus. When we look back the mind map, if the result of the completing the square is a plus, that is, we are going to use either substitution or formula. So now I decide to use a substitution method. That is, fx is equal to square root of 2 times x plus 1 over 2 and a is equal to 1 over square root of 2. So when I substitute, I'm going to substitute square root of 2 x plus 1 over 2 with 1 over square root of 2 tangent theta, and after differentiation, now I get dx is equal to something like this. Okay, now I'm going to replace the fx with 1 over square root of 2 tangent theta, dx replaced with this. Now, for this power 2, 1 over square root of 2 power 2, we get 1 over 2 tangent power 2. Now, I factorize 1 over 2 and I will get tangent power 2 plus 1. Tangent power 2 plus 1 is equal to sec square. And notice that we can cancel off these two terms and finally we get 1. Now I'm going to substitute this back into the equation number 1 just now. So now I get this one. So notice that I can easily integrate this one to get theta. Since the question is given in terms of x, now I'm going to change theta into x. To do this, we look at the substitution just now. From square root of 2x plus 1 over 2 replaced with 1 over square root of 2 tangent, then means when we rearrange this equation, then I get theta is equal to arctangent 2x plus 1. So now I substitute theta with arctangent 2x plus 1, then that is the final answer. Now let's try another question. For this question, the rational function is in the form where the numerator is linear and the denominator is repeated linear factor. If the denominator is repeated linear factor and the numerator is linear, then I'm going to change the numerator into the linear factor. Notice that now the numerator is x plus 1 and the linear factor is x minus 2. So now I'm going to insert minus 2 and plus 2. Now I get x minus 2 here and 2 plus 2 becomes 3. And I'm going to separate this rational function into two parts. One is for x minus 2, one is for 3. After separate, I notice that I can cancel off one of the linear factor, that is x minus 2. Now to continue the integration, now I'm going to change the power becomes negative. After that, I find that I can easily do the integration and finally I'll get the answer. In the mind map that I show you in this video, we found that the highest power of x of the denominator in this mind map is up to power of 2, that is quadratic. Then how about if the question given where the highest power of the denominator is greater than 2? For example, this question. So for this question, the highest power of x of the denominator is power 3. So in this case, first we can double check whether we are able to factorize the denominator. For example, this one, x power 3 plus 1 is a reducible denominator where we are able to factorize this denominator. And by using the theorem factor that we have learned in Sem 1, we find that we can factorize x power 3 plus 1 into this. And followed by partial fraction, now we separate this function into 2. So notice that after factorize the denominator, now the highest power of the denominator has been reduced to the lower one. Now the following step is we just need to choose the suitable method for each of these integral to find the integration. After we have gone through so many questions just now, I simply hope that this will give you a basic idea about how to integrate some simple rational functions. The method that I use in this video actually is not 100% or compulsory to be used. If there is any other method which is simpler or better than the method that I used, so just go on. And the important thing is you need to practice a lot in order to master in the technique of integration.